Thank you very much to be here. So I'm Stéphane Woillez. I'm technical sales lead at Docker. I cover the SaaS Europe region. And today I will talk with you about serverless, this new development and operations technology, and the implication of serverless in the way we develop and operate applications. When I tried to build this presentation, I actually looked back in the past at my early days of developers, trying to find similarities of what I have done with serverless. And here is a couple of very old pictures. This is my actually second computer. It's an Apple IIe. It's a long time ago, back in 1984. So yes, I'm not that young. I started programming in BASIC, and actually my first program was a kind of RPG, a role-playing game. It was text only, and it was waiting for the actions of the player in order to move the character in some kind of fantasy land, and from time to time spawn some monsters for the player to play. My next computer, oh, that's me in the picture, much younger than today. My second computer was a PC, and I moved. If you are close to the screen, you can see that there is a book just aside from my arm. It's written Turbo C. That was my second language. The reason why I am talking about these early edges of programming is that even at those days in 1984, the way I programmed was event-driven. Remember, my APG game was waiting for some kind of event coming from the player. And today, serverless is really about waiting for events and reacting to events. This is one of the core principles of serverless. But let's move ahead and maybe talk a little bit of serverless and state the basis of serverless, because many people have different definitions of serverless and talk about serverless in different ways. So there is one definition, which is the ultimate definition of serverless. It's written by the CNCF, the Cloud Native Computing Foundation. So let me read it with you. Serverless computing refers to the concept of building and running applications that do not require server management. That does mean that you write something, but you don't care about the server. That doesn't mean that there is no server at all, and there is no operations at all. I'm happy about that, because as I am in the business of containers, I'm happy that there are still servers and containers to run all of these. So that's the definition, but there are many people that are assimilating serverless with what we call FAS, or function as a service. That's very similar, and many frameworks of function as a service are called serverless, and I don't agree a lot in doing serverless with only a function as a service platform. For me, serverless is not only function as a service. So a function as a service platform is basically a platform into which you can push some code to create a function, and then the function is just executed somewhere, and you can call it, it's scalable, it's everything. But that's not a serverless platform. You need a lot of things, a lot of additional things. If you think about the current applications that we all develop and manipulate, there is the application itself, and there are also things in the backend, like databases, like storage. So if I think about a serverless platform, it's not only function as a service. There should be somewhere a backend as a service into which you can hook your functions to manipulate data. So for me, FaaS, function as a service, is one part of the serverless platform, but alone it is not a serverless platform. If we think about function as a service, and think about if this function as a service allows you to just write some code. So I write a bit of code and I push my code to the function as a service platform. And then there are some magic happening while I am pushing that code to the platform. Something is probably built, something is probably created in order to for everyone to access my code. But after a couple of milliseconds or seconds, my functions appears magically on the function as a service platform. It should be working, callable, scalable, and nothing has to be done to manage these functions and the scalability and the security, and everything should be automated. So that looks magical. And we need to open a little bit that box in the center of the screen in order to really understand what is underneath that magic and understand how we can operate the magical stuff of function as a service. So actually looking at how to really implement serverless, there are things that happen, things that are good, and things that are less good today. You will see that there is still a lot of work to do in order to build a complete functional serverless platform. So let's go ahead and look at different aspects of serverless and how it works and the limits of them. First, use cases for serverless. Some people say that serverless can implement everything, every kind of applications. Actually, that's not really the case. If you look around the internet and the different publications about serverless, you can see many different kinds of use cases for serverless, like stateless processes or data stream processing or IoT processing. When you get events, you can call some things to manipulate data and do kinds of actions. If you look throughout all of these use cases, there is one behavior that just appear to be part of all of these use cases. And that comes back to my early programming experience. It's about event-driven architecture. So the functions of a serverless platform are just called by some kind of event, some kind of things that trigger them. And that's exactly what you have to keep in mind when you develop serverless. It's about programming things that reacts to something, reacts to events, reacts to something that you can trigger. And that's one thing. And then we go into some kind of limitations today of serverless platforms, things that serverless can do, and the limitations. First, look at operations. So yes, when we all talk about serverless, we say that operations are just gone because you are a developer and you push your code to the serverless platform or to the FaaS platform, and that's it. Nothing to manage, nothing to secure, nothing to do. It's automated, and that's good. But actually, if you really dig into that question of operations, there are aspects of operations that are not well or not yet very well managed today. Like, for example, we all think about public cloud. And yes, there are many public cloud serverless platforms like AWS Lambda. And there is no magic inside. There are many people and many things that operate the platform underneath the Lambda platform. That's one point to execute serverless or functions in the cloud. But what about on-premises? How do you implement such a platform like AWS Lambda on premises? How many people you will need to just operate this type of platform? Another question that raised very quickly when you think about serverless, because no one talk about production, non-production, test, integration. Everything should be automated, and you can just give version numbers to your functions, and you push a new version of your function directly to production, and you can untitle your production as a development code, so that no one but you can access the code and test it. That's an option. But do you really want, if you are part of the operations, you are in charge of the data center running production environment, are you really want to execute code that is not tested directly into a production environment? That there are very few operation directors that will allow you to do that. So there is really a need of different environments, even in serverless, in order to ensure that what you run in production is really tested. It's not about access or not access it by different categories of people. It's really about be sure that the code that you push into the production is really exempt from any kind of bug that will just trigger a chain of reactions in the production and just kill your production. Another question is about the impact of the performances of your function to a given application. It's very easy to monitor the performance of one function, but one function in a function as a service platform is not an application. I mean, there is an addition of many calls to many functions that makes actually the application itself. So how do you identify which of the hundreds of functions that you call in your application is killing the performance of your application? So there is really a need to monitor the calls of each applications and link all of these calls to the others in order to create a kind of monitoring of the overall application. And another question that raised, and if you are in the container world, you already have that problem because you probably manage a lot of container images. You have a kind of registry, and after a while, managing your registry, you can discover that there are a lot of images within your registry that are actually not used at all. And you are using a lot of space on your registry, wasting this space. And that will be the same for functions in a function as a service platform. How do you know that the hundreds of functions that are actually pushed to your fast platform are really used and will not be used? So there is a kind of governance to operate in order to figure out that the functions are really used or not in your platform. Another aspect is about application development. So yes, I develop some code, and I do not care if this is about function as a service. I do not care at all about the server anymore. I don't care if this is Ubuntu, Red Hat, SUSE. It's just code, right? So I put it, I push it into the platform, and that's it. And doing that, and the fact that each developer is only responsible from his function and not the overall application, you can parallelize a lot of things. So the speed of development increases a lot with function as a service. There is a maximum agility with that. But again, if you think a little bit further about that, there are things that you have to care about when you develop functions. Like, for example, you are developing a very good new functions, very interesting, that you want to push to the platform. Maybe the thing that you are working on today is already on the platform, already developed by someone else? How do you know that what you are doing is just a waste of time because someone has already developed your application? So you can see now that there is a need of such a catalog of functions that you can query in order to ensure that what you need to have in terms of functions maybe already exist and you don't have to develop it. Another question is about the application itself. As you can see, a new application based on functions will not be only 1 or 10 functions. It will be a kind of workflows or of calls of functions to other functions. And that makes your applications. And very large applications can call hundreds of functions. How do you draw the boundaries of your applications? How do you know that which functions are you using on the function as a service platform? How do you monitor that function? That is also something that we have to build. And what about debugging? There are many people saying that it's easy to debug a function as a service because you are only responsible of a little piece of code, which is your function. And that's true. I mean, it's very easy to debug 50 lines of code than hundreds of thousands lines of codes. But an application is not only 50 lines of code. Again, it's a group of tens or hundreds of functions connected together, called by some workflows. How do you debug logic issues in your functions? Like something is going bad on one aspect at one point of your workflow, of your data workflow, and you need to figure out where exactly among these hundreds of functions you have an issue in your workflow. So there is a need of a tool that will allow you to basically follow the workflow of execution of your applications from one function to another function in order to figure out exactly where you may have an issue. If we talk about security, because this is a very interesting and debated aspect of serverless, there are some very good aspects of serverless. Like, for example, you develop only a very small piece of code. So the smaller is the better in terms of security. The smaller your code is, the less you will have potential vulnerabilities in your code. That's true. Another aspect which is very good with serverless is that serverless is made of stateless functions. The state of the application is outside, stored somewhere in the data, but most of the code is stateless. And stateless is very interesting in terms of security because you cannot do things like long-running attacks because there is no state. You cannot store something somewhere within the code and go back to that code after weeks to run your long-running attack. So that's good. But actually, there are things that we miss in such platforms, like how do you protect data? There are hundreds of functions accessing different type of data. You need to protect data. I mean, we manipulate with our applications many kind of data. Some of them are very critical, important, secrets. So we need to protect access to the data. So how do you do that? How do you inform or how do you pass on credentials to functions in order for the functions to get access to the right data with the right credentials? If we go on with security, how do you secure the access to the functions? I mean, some of the functions may be developed to do very critical aspects or very secure or confidential things. How, within the flow of applications, do you pass on, again, credentials on behalf of the user, for example, that will allow you to get access to functions or not? How do you implement network isolations? I mean, even with containers, you can implement some kind of isolations. Actually, when we create containerized applications, The network isolation is automatically built by the Docker engines and the Docker clusters by creating the VLANs or VXLANs between the different part of the applications. It's much more difficult with functions, where all of the functions basically are stored on the platform, and you do not. It's very difficult to segment them into different categories. So there are very many things, many aspects of security that we have to work on in order to ensure that serverless platforms can run in production safely. So going back to my first schema that I showed you of what is a serverless platform with the function as a service, and the backend as a service. That is the definition of today. Let me give you my view, considering what I've just told you about what is a serverless platform architecture designed for production. So we will just take all of what I've just said and put it back into the schema. So I told you that we need something more than just a production environment. So there is some kind of need of a pre-production or something near production, close to production, so that will allow you to have a behavior very similar to production, but still match the requirements of security officer or of the production that really wants to segment production and non-production. In order to manage the link between the two, as well as other aspects of the management of the code, DevOps is still very necessary for such platforms. We talked about a functions catalog. So definitely, we need to have a function catalog on top or aside from the platform, something that you can query for existing functions with tags or things like that in order to ensure that what you develop is not already existing and on which you can just look for functions for a given behavior. We need to monitor and we need to log things within the platform. And this is a very short center just to fill into the box, but you can understand now that there is some aspect of the distributed world of serverless platforms that needs to be worked in order to implement such a monitoring and logging tool. And on top of that, we need a very layer of security to secure the data, to secure the calls to the APIs, to secure the access to the platform. If we come back to the title of my presentation, first, will serverless kill containers, kill the whale? And second question is, will serverless kill operations? I think not, actually. If you look at the inside of function as a service platforms, most of these platforms, all of them almost, they run on top of containers. They need containers to have this agility that serverless platforms bring you. And there are aspects that containers can do that function as a service cannot. Like, for example, remember that function as a service is a stateless platform, and it's not easy to implement stateful applications. With containers, they are agile enough to implement big, large applications into containers in a stateful environment. So I think also there are things that we can do with containers in order to abstract containers and bring something that is container-free to the developer. The developer thinks only about his code and not about containers. So those aspects mean that, well, containers are a big, good additions to serverless. Regarding operations, I think you are convinced by my talk there is definitely a need for operations. Today, we are at the very beginning of designing serverless infrastructures. We are actually thinking about function as a service, but you can see that there are many aspects of a serverless platform that are beyond function as a service. We have a lot of things to invent, to create around serverless. Governance, the way we operate serverless platforms has to be designed. There are things like responsibility, who is responsible for the productions, what is the link between the production and the developers, that needs to be done. The cost at scale is an aspect of cloud that we know. We need to design applications for cost, and that's the same for serverless. It's another aspect. I've not a lot of time to talk about that, but this is definitely an aspect of design for serverless architectures. Let me recap. 2 minutes, 1 minute, 0 minute, 1, cool. So about the question of my session, serverless runs event-driven stateless application, most of them. That's the concept of serverless. And most of those platforms run on top of containers. Containers are a bit more agile in terms of they can implement more type of architectures, more type of applications than we can do with serverless. So definitely, I see the future, the near future, of a kind of co-work between serverless and containers. Some aspect of the applications will run in serverless, and some other aspect of the applications will still run into containers because containers are more suited for this type of components. In terms of operations, again, serverless is much more than function as a service, and you have to, in order to implement a serverless platform, you need much more than function as a service, and you definitely need people operations to operate this platform. So, in summary, to my opinion, this is complementary. Serverless and containers are complementary and can work together to implement applications. They are good and less good in the two technologies, but the two of them together can be very, very interesting. And operation will not disappear. I mean, this is not the end of operations. I think that this is a shift of the role of operations and the way operations are done with such serverless platforms. Well, thank you. If you have any questions, don't hesitate.
Thank you so much.